Hello, this is Mr. Craig, and this is day 18. This is actually your solubility rules and writing equations, precipitation reaction. And I hate to say this, guys, but this is probably one of the more difficult things that you're going to have to do for the next week. And the key here is, it's not a very difficult task. It's just that in general chemistry, you were given something that you're not able to use now, and you have to memorize. It's called solubility rules. Now, back in general chem, we had precipitation reactions where we had a double replacement reaction, and you were looking to see if there was a formation of a precipitate. If you had me in class, I actually mixed things together, and they started off clear, and then they went cloudy, and unfortunately I can't insert a video in here for this. And if I have the ability, I'm going to try very hard to insert a video later on to demonstrate what I was talking about, especially in this video here. But I'll have to do Movie Maker, and I really hope that I can get it to work out. But the key here is we're looking for the formation of a precipitate. And what a precipitate is, it's a cloudy substance. The solution begins clear, and then it turns cloudy. And it's no longer transparent or clear. That's probably a better phrase to say. All right, now, we all know how to do double replacement reactions. Like looking at question number 1, where we have ammonium carbonate, and we react that with zinc chloride. We all know how to do double replacement reactions. At least we should know how to do double replacement reactions. What you need to be able to do after you do the double replacement reaction, well, let's do the double replacement reaction first. Again, double replacement reactions mean that we're having partner switch. Metals are going to switch, compounds, or nonmetals are going to switch. What we don't want to do is put the metals with the metals and the nonmetals with the nonmetals. These are ionic compounds. These are ionic reactions. So what we want to do is we want to have partner switch. And probably the easiest way to do this is just say, hey, the metals are going to switch. So the ammonium is with the carbonate, but on the other side, the ammonium will go with the chlorine. Okay. Now, what we don't want to do, we do not want to do this. We do not want to carry subscripts unless it is attached to a polyatomic. Like, for example, the NH4, there's my subscript, 4. Notice that on the chlorine there's a 2 there. We don't carry subscripts unless it's attached to a polyatomic. Now, you also may have noticed, well, outside the ammonium, there's a parentheses and then a 2. Again, we're not carrying the 2, we're only carrying the thing that makes up the ammonium. So the NH4. All right, and then the other product here is the zinc will go with the carbonate. Okay, and we just want to write these out first. Okay, then we'll go to our periodic table, or we'll refresh our memory on how to remember the charges here. But we want to write out the products, and it's only the products that we're concerned about with these types of reactions. So the partner switch, we want to make sure that the metals are always written first. And how do you know it's a metal? You know it's a metal because it has a positive charge. So the ammonium has a +1 charge, the zinc has a +2 charge. How do you know that? Well, we let our nonmetals tell us for one way. Also, you want to look at the periodic table. Okay, so let the periodic table help you to determine the charge of some of the things that you're probably not so familiar with. Now, earlier on, and it might have been a couple of weeks ago in the lecture, one of the first things we talked about the aluminum slide. In other words, when you look at aluminum here, and then if you move in a diagonal direction down to zinc here, zinc has a +2 charge, the silver here has a +1 charge. The aluminum slide, it starts at 3, 2, 1, and these are all positive charges because these are metals. So when you hear me refer to the aluminum slide, I'm helping you to remember what the charges are for zinc and for silver. And the nice thing is, zinc and silver only have a single charge, and you need to memorize that. Now, however, if we look at like copper and nickel and cobalt and iron, these all have multiple charges. We're going to let the nonmetal tell us what the charge is for that. Okay, that's the nice thing. All right, so going back to the problem. Now, you probably said, well, how do you know that the ammonium has a +1 charge? Well, that goes back to one of the first lectures that we had, memorizing 10 polyatomics. So if you have not memorized the 10 polyatomics formula, charge, and name, you have two things that you now need to memorize. Okay, so you need to know the 10 polyatomic ions, and you're going to need to memorize this. And I believe I gave this to you. If I did not give you this sheet, and I'm pretty sure that I did, this is the solubility rules. You need to know the solubility rules for the rest of the year. Okay? Now, you had a different looking sheet that was given to you to help you predict the things that form the precipitates in General Chem. The bad news is you do not get a sheet that tells you what forms precipitates on the AP exam. However, the nice thing is that these are the only things that we need to know. Okay? So how are you going to memorize all of these different rules here? You're going to make flashcards. My suggestion is make flashcards. Write the rule on one side and then put the polyatomics on the other side. That's the best way to do this. And I'll go through each one of these rules here shortly. Alright, so getting back to the charges, we have to have a balanced equation. Okay, it's nice. You always, whenever we write a chemical equation, we want to make sure it's balanced. But first, we have to make sure the charges are balanced. So what we need to do first is make sure that we have the correct charges and the correct number of atoms on both sides. Okay, so ammonium has a +1 charge. We know that because we memorized that ammonium has a +1. Chlorine, and again, if you don't remember chlorine, that's fine. Let the periodic table tell you what the charge is. Again, everything in this column, if we have just fluorine or chlorine or bromine or iodine, they will all have a -1 charge as a nonmetal, okay? Because it's one group away, or it's one column away from the noble gases. And again, all things want to have the same electron configuration as its nearest noble gas, whether it's a metal or nonmetal. That's why nonmetals gain electrons, and metals, the nonmetals gain electrons where the metals itself lose electrons. So nonmetals gain, metals lose. That's why metals have positive charges, and that's why nonmetals have negative charges. All right, so chlorine has a -1 charge. So if chlorine has a -1 charge, this compound, ammonium chloride, is balanced as written. Looking at the next one, the zinc carbonate. Again, we just talked about the aluminum slide. So the silver, the zinc, and the aluminum, zinc, and silver. So zinc has a +2 charge. Goes 3, 2, 1. Moves diagonally. Okay? So zinc has a +2 charge. Whoops. And the carbonate, based on memorizing 10 polyatomics, has a -2 charge. So my compounds are balanced as written. However, I don't have the same charges on, I don't have the same number of atoms on both sides. You'll notice that there's a 2 over here for the ammonium. You'll notice there's a 2 here for the zinc. So what that means is I need to have 2 ammoniums and 2 chlorines. That is, I now have a balanced equation. Let me erase these arrows here. Okay. And my charges I can get rid of. All right. So now that I have my balanced equation, and I'm happy, I need to see which one of these compounds is quote-unquote not soluble. Not soluble means it's forming a precipitate. If it is soluble, that means it dissolves in water. Okay? All right, so let's look at our solubility rules. First one says all nitrates, chlorates, and acetates are soluble. Okay? All nitrates, chlorates, and acetates are soluble. So if I have something like sodium nitrate, soluble. Okay, that means it remains clear. If I take a piece of solid sodium nitrate and place it in water, that will dissociate, or it will dissolve 100%, and it remains clear. It looks like a glass of water. Okay, same thing with the chlorates and acetates. So anytime you see a metal in front of the chlorate, acetate, or nitrate, it is soluble. So do we have any nitrates, chlorates, or acetates in this first problem? Nope, sorry, we don't. Okay? All right, number 2. All alkali, salts, and ammonium are soluble. Okay? Number 2. All alkali, salts, and ammonium are soluble. Now, don't get hung up on the word salts here. Okay, I don't want you doing that. Salts is a very generic term. It means most ionic compounds. We don't need to worry about that. Okay, alkali, actually alkali metals, probably a better way to say that. That's this column right here, group 1. Okay, so when we look at hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, yeah, it's there, but there's nothing on it. We have a very small amount of francium here on Earth. Okay, anytime that you see one of these metals, it is soluble. We can also place ammonium in group 1A because it has a +1 charge. And all of these have a +1 charge as well. Okay, do we have any group 1A or ammoniums in this first problem? Yes, we do. We have ammonium. So we know that the ammonium chloride is soluble. We know that it's going to be clear. If I take a piece of ammonium chloride and place it in water, it will dissociate 100% and remain soluble because of the ammonium. Okay? All right, so now we just have to look at the zinc carbonate. Let's continue on with the rules here. Number 3, all chlorine, bromine, and iodine salts are soluble, except with silver, lead with a +2, and mercury that has this goofy combination. Now, unfortunately, you will not see any H2 with a +2 in my homework. You may, once every 3 or 4 years, they'll throw it at you on the AP exam. That's why I have it on here. But primarily what you need to focus on is silver and lead. So if you see silver with chlorine, bromine, or iodine, or lead with chlorine, bromine, or iodine, that forms a precipitate. Okay, so let's take a look. So we have chlorine, but it's not with silver or lead. So again, that's another reason why this is still soluble. Okay? All right. Number 4, all sulfates are soluble, except for barium, lead, mercury, and calcium. Now, about 4 or 5 years ago, I had a student, and we always come up with these mnemonic statements or sayings. And this is kind of funny. I don't mean to be mean or offend anybody when I say this, but all sulfates are soluble except for cold beer and Pizza Hut. Okay? When I say cold beer, it's the first letter. Calcium, cold. Beer, barium. Pizza, lead. Hut, mercury. Okay? So all sulfates are soluble except with the cold beer and Pizza Hut. Now, again, it's not with cold beer and Pizza Hut. It's with the lead, the barium, the mercury, and the calcium. Okay? And probably, if you need to look at the periodic table is always going to be available. So you've got your calcium here, you've got your barium here, you've got your lead over here, and your mercury right here. So, and again, how you memorize these is up to you. Okay? So, all sulfates are soluble except for with cold beer and Pizza Hut. And if you say it over and over and over again, this is how you learn it. All right, so do we have any sulfates? We do not. So let's continue on. All right, number 5. All hydroxides, OHs, are not soluble except with group 1A, ammonium, calcium, strontium, barium. These are soluble. Now, one way that I say this, if you're looking at the periodic table, all hydroxides are not soluble except for group 1A and then calcium on down. Okay? Again, all hydroxides are not soluble. In other words, they will form a precipitate except with group 1A and calcium on down. Now you might say, well, wait a minute, radium's not in there. True, we're never going to talk about radium. But it's just easier to memorize calcium on down. Okay? Any other metal in front of hydroxide forms a precipitate. Beryllium hydroxide, magnesium hydroxide, and then everybody else. Okay? So they all form precipitates, except group 1A and calcium on down. Okay? And again, that's why I'm saying that these are simple rules. If you use these statements, it'll help you. Okay? All right, number 6. All sulfides, carbonate, chromates, and phosphates are not soluble, except with group 1A and ammonium. Okay? So going back to our question, I think we have one of these. Sulfate, carbonate, chromate, and phosphate. So, yes, we do. We have zinc carbonate. So, is zinc a group 1A metal? Okay. Is it a group 1A? No, it is not. It's actually a transition metal, which is over here. So, what that means is we have our precipitate. So, what we want to do is we want to circle it. Can I undo that? Yeah. What we want to do is we want to circle it, circle the precipitate. And I don't know if you did this in general chem or not, and it's okay if you didn't because you'll learn it here. You're going to circle the precipitate and write PPT. What that means is precipitate. Okay, that's a nice little abbreviation for precipitate. This tells everybody that we have a reaction. If the ammonium chloride would have been clear and the zinc carbonate would have been clear, or they both would have been soluble, then you would strike a line through it and write NR. Okay? However, that's not the case. Okay? So since we have a reaction here, and we can have more than one precipitate, it's just not very good chemistry to do that, but you could. We want to circle the precipitate and then write PPT. Okay? All right, now let me go and finish the rest of these. The last one here. All metal oxides are not soluble except group 1A and ammonium. Okay? So hopefully you're saying this to yourself that any time that we have a compound and it has a group 1A metal and ammonium, it's soluble. Anytime you have nitrate, acetate, chlorate with a metal, any metal, it's soluble. Okay? And I want you to make flashcards. I really want you to make flashcards. It will help you. You only have to make 7 of them, okay? 1 for each category. And really, you only need to make 6. You don't need to make it for the first one. But the first 2, hopefully, okay. All right, let's look at letter B. We have barium chlorate and copper sulfate. Okay, so let's see, what are we forming? Well, again, we're going to have the metals switch. And it doesn't matter if you write the barium first. The barium sulfate first. Again, what we're going to do is we're going to have the metals switch. It doesn't matter if you write the barium sulfate first or if you write the barium sulfate second. Doesn't matter, just as long as it's on the respective and correct side. And then we're going to have copper, and again, write the metal first with the chlorate. And I only want you to write 1 of each before you start doing anything. Don't carry parentheses. Don't carry subscripts unless it's part of the poly. Okay? So let's balance charges. Barium, +2. Sulfate, -2. How did I know barium was a +2? Again, my periodic table told me. So if I click on it, barium is in group 2A. Those all have +2 charges. Group 1A, +1 charges. Over here, above the boron, if it's a metal, we have a +3 charge. Now, here with carbon, it could be difficult, we'll say. But most of these have a +4 charge, but carbon can have a -4 charge. Also, carbon can have a -2 charge. I think it can have a +2 charge as well. Carbon's kind of goofy. We're going to kind of stay away from carbon. But then we jump over to nitrogen. This column here, the nonmetals, have a -3 charge. Oxygen, these nonmetals have a -2. And like we said earlier, these have a -1. Noble gases, no charge. So don't go crazy on me there. All right. So the barium and sulfate are balanced as written. Copper has more than 1 charge, but we need to know what the charge is. So I'm going to come back here and look at my compound, and I know that sulfate has a -2 charge. And how many sulfates do I have? I have 1. So that means since I have 1 copper, it has to have a +2 charge. Now, the charge is going to remain the same. Okay? In double replacement reactions, the charges don't change. In single replacement reactions, the charges do change. Okay? Double, no. Single, yes. Okay? All right, and then the chlorate, again, since it's one of your 10 polyatomics, has a -1 charge. And if you forget, then hopefully from writing this out, you'll be able to remember, oh yeah, chlorate's got a -1 charge. You'll memorize that again. All right, so +2 -1, that means I need a parentheses and a 2. I did not bring the parentheses and a 2 over because it's here. Okay, I brought it over because I needed it. The metals just so happen to have a +2 charge on both sides here. Oops. All right. Let's see, who is, and let me Kind of zap these. Okay, so now that I have my balanced equation, now I want to find out who forms my precipitate. Let's take a look at this one first. Okay, copper chlorate. Remember rule 1? All nitrates, chlorates, and acetates are soluble. So this is soluble. So that's not going to form precipitate. Looking over here at the barium sulfate, all sulfates are soluble except, that's right, cold beer and Pizza Hut. Very good. So rule number 4, and you don't have to know the numbers, just know the rule. So sulfate, since it has barium, it's not soluble. Okay, so all sulfate salts are soluble except when it's with barium, lead, mercury, or calcium, or cold beer and Pizza Hut. So my precipitate for this reaction is right here. So circle it and write PPT. Okay. All right, letter C. And again, pause the video at any time and attempt these for yourself, please. And it's okay if today you're using the sheet, the rules, but since you're at home and you're doing this over the summer, try to memorize the rules here. Make your flashcards before you attempt the homework. That might help. In class, we didn't have the time to do that, but hey, this is a summer. You've got a bunch of time here. All right, so again, let's write out our products. So we'll have sodium with the nitrate, and again, if you wanted to write sodium nitrate as your second product, no problem. And then I'm having the lead with the oxygen. Okay, so now let's balance charges. Sodium has a +1, nitrate -1. That compound's good. Lead, since nitrate has a -1 charge and we have 2 of them, that means that the lead has a +2 charge. And oxygen, well, we know oxygen always has a -2 charge, so we don't have to worry about that. Get off of there. Hopefully you know that oxygen has a -2 charge. Come on. Okay, so oxygen has a -2 charge, so that compound's written as balanced. However, we do not have the same number of atoms on both sides. So I have 2 nitrates here, and I have 2 sodiums here, so put a 2 in front. Now, once you have the compound balanced charge-wise, don't get creative and start putting subscripts in after you've balanced it out, okay? That's when we use our coefficients. All right, looking at the first one, sodium nitrate. And let me erase these charges. Oops. Erase, please. Okay. So, hopefully, just by reading these rules out loud a couple times, you already know what the answer is. Sodium nitrate, is that clear or cloudy? Does it form a precipitate or does it remain soluble, is what I mean. If I say it's clear, that means it's soluble. If it's cloudy, that means it forms a precipitate. All right, so sodium nitrate, actually for 2 reasons this is soluble. Because it's a group 1A alkali and it has nitrate, so it's double whammy. Now that doesn't mean that it's doubly soluble. It just means that it's soluble. It is or it isn't, okay? It's kind of like saying that I'm kind of pregnant. No, you either are or you aren't, okay? So don't try to swing it one way. It is or it isn't. All right, looking at the lead oxide, remember rule 7 said that all metal oxides are not soluble except for group 1A, period. So lead, last time I checked, lead was not in group 1A. Yeah, it's over here. So the lead oxide does form a precipitate. So circle it, right, PPT. Okay? All right. And the rest of these examples are just like this. Okay? Except here I gave you the formulas. Here you get to write out the whole thing. Now, again, I'm still mainly concerned about the products, but when you're given word questions like this or word problems, you need to write out the whole equation and balance it. Okay? We're still going to balance things out. All right, so let's look at this. Again, same rules. If they're both soluble, no reaction. So we haven't had one of those. And I doubt if we do have one of these. All right, tin,4 acetate. Well, tin is SN. Remember, it's a SN to 10. And it has a +4 charge. Acetate, C2H3O2, has a -1 charge. And we'll come back to that here in a minute. And sodium bromide has a +1. Bromine has a -1. We'll come back to that. Okay. So on the other side, the metals are going to switch. So we'll have tin bromide. And again, they keep their charges. So +4, -1. And then the sodium with the acetate. Remember, write the metal first. +1, -1. Okay. So it looks like that one's balanced and that one's balanced. So we need to balance these. So tin has a +4 charge, acetate -1. That means we need 4 of those. Over here, tin has a +4, bromine has a negative. Oops! Did you see what I just about did there? Don't ever write a parenthesis around a element. Oops. So we need a 4 there. Okay. Parentheses, polys. Parentheses are for polys only. All right. So we have our balanced equation. Let me kind of scoot that over a little bit. Let's go over our solubility rules, and we only care about this side. Okay. We only care about our products and solubility rules. Sometimes I will give you a solid on the reactant side. And typically when we start with a solid, then you're reacting it with an acid, and it'll dissolve it, and maybe form a different precipitate on the opposite side. But we only focus on the product side, okay? And that helps. That'll speed things up too. So the tin bromide, looking at your rules, said that all, chlorine, bromine, and iodides are soluble except with silver and lead. Doesn't say anything about tin, so that means that that is soluble. Okay, does not form a precipitate. Sodium acetate, is that soluble or not soluble? That's right, it's not, or it is soluble because of 2 reasons. We have acetate, and what was it, sodium, and it's a group 1A metal. So what we have here is a line and no reaction. Nothing's going to happen. These will be clear on this side. When I pour them together, they'll still remain clear on this side. It's a bummer. And I really do hope that I can infuse a video showing that for you. All right, magnesium hydroxide and nickel 2 nitrate. Again, let's write out what we know. So magnesium hydroxide. Magnesium has a +2 charge. Hydroxide -1. And then we have nickel with a +2 charge and nitrate with a -1. Okay, we'll balance that here in a minute. Then the metals are going to switch. So magnesium is going to go with the nitrate. And the nickel will go with the hydroxide. Again, +2, -1, +2, -1. Now again, I know it's a +2 because of Roman numeral. Okay? Nickel can be either +2 or +3. You don't need to know that. You do not need to know that. Okay? Alright, so let's balance these out. So magnesium's +2, hydroxide's -1. Yes, show parentheses, even though there's no subscripts on that hydroxide. Because if you don't show parentheses, that means you have 2 hydrogens and still 1 oxygen. Not good. +2, -1. Again, 2 with the parentheses. Looks like we're going to do it to all of these. Yay, isn't that fun? Alright. Magnesium nitrate. Let's look at, again, our products here. Magnesium nitrate. Is that soluble or not soluble? Focus on the nitrate. What's the rule with nitrates? All of them are soluble. Okay, so all nitrates are soluble. So the first thing is not going to form a precipitate. However, the nickel hydroxide, what's rule 7 say? Or not 7, but I think it's 5 or 6. 5, that's it. It says all hydroxides are not soluble. Okay, are not soluble. Means forms precipitates. Except for group 1A and calcium on down. Okay, so group 1A, group 1A, and then calcium on down. Well, nickel just so happens to be right here. So it's not in group 1A or calcium on down, so we do have a precipitate. So So circle it and write PPT. Okay. All right. Letter C, silver nitrate. And again, we'll come back and balance these. Silver has a +1 charge. How do I know silver has a +1 charge? The aluminum slides. So 3, 2, 1. There's silver. Okay. And nitrate's -1. Actually, that's balanced as written. Potassium, +1. Chlorine, -1. All right. These are all 1s. And then have the partner switch. So we're going to go silver chloride and potassium nitrate. Okay. And again, they're all +1, -1. So they're all charges of 1. So the chemical equation's balanced as written. All right, so let's look at solubility rules. Silver chloride, is that clear or cloudy? Hopefully you said that is going to form a cloudy substance. Because again, all chlorines, bromines, iodines are soluble, except with silver. So there's our precipitate. So circle it, write PPT. But again, check and make sure that your other is clear or cloudy as well. Now, is it clear or is it cloudy? Where's potassium at on your periodic table? That's right, group 1A. Nitrate. All nitrates are soluble. So this is soluble because of group 1A and nitrate. Okay. All right. Number 3. Net ionic equation. All right. When we talk about net ionic equation, we're talking about the equation that shows the formation of the precipitate. Okay? What I've actually been doing up here isn't even the ionic equation. Okay? This is just the balanced equation with the formation of the precipitate. Question number 3 is actually how the AP exam will be asking you to answer this. Okay? So when we get closer to April, actually right after spring break, we're going to go over net ionic equations again. Okay? And it's a very, very simple process. We want to keep the things that don't change. Okay? If it's an ion on the left side and it remains an ion on the right side, in other words, it's soluble on the right and it's soluble on the left, then that means it hasn't changed. I'll give you an example here. Lithium sulfide. Okay? So we have lithium sulfide. Lithium has a +1 charge. Sulfur has a -2. And that reacts with aluminum bromide. Aluminum has a +3. Bromine has a -1. Okay, so we're going to have our partner switch here. And we'll balance charges here in a second. So lithium and aluminum are going to switch. So we'll have aluminum sulfide. And again, we'll balance these out here in a second. And then we'll have lithium bromide. Okay, +1, -1. Well, my ones are really drawing well today. Okay, so we have our things written out here. Let's go ahead and balance charges. So I need 2 there because it has a +1, -2. Aluminum has a +3, bromine, -1, so I need a 3 there. Here, I've got a 2 here, so I need to put a 2 there. I've got a 3 here, so I need a 3 there. Aluminum sulfide, and this is balanced as written. Okay, balance atoms out now. Okay, so I've got 2 lithium here, and I have 3 bromine here. So 2 and 3 means I need a 6. I have 2 aluminum. I need a 2 there. Hey, there's my 6 bromine. Probably I should have started with the ugly one first. Start off with the aluminum, 2, 2. Then that gives me 6, 6, 6 lithium. Means I need a 3, 3 sulfurs. Boom, I'm balanced. Okay, so I've got my balanced equation, my balanced formulas. All right, now let's find out who forms my precipitate. Aluminum sulfide. Okay, solubility rules. When we talked about, oops, come on, click on it. Looking at sulfur, carbonate, chromate, and phosphate are not soluble except with group 1A and ammonium. Okay, so looking at aluminum, aluminum is not in group 1A, nor is it ammonium. So that means it forms a precipitate. So we can circle that. Say, hey, we got a PPT here. Okay. Lithium bromide, we have a group 1A metal. So we already know that that's going to be soluble. Don't even worry about going any further. All right, so this is the balanced equation. It's not even the ionic equation. When we talk about net ionic equation, I want you to tell me what makes up the components to form the precipitate. Well, how many aluminums do we have here? Well, we have 2 aluminums with a +3 charge. This is soluble, this is soluble. Okay? Again, what I'm doing is I'm trying to show the net ionic equation, and again, we only include those components that make the precipitate, and we include them all. Okay? And then, what else is in our sulfide? Well, we have sulfur here, and how many sulfurs do we have? We actually have 3 sulfurs with a -2 charge. Okay? And how do I get that? Well, I have 3 with sulfur, and again, this is soluble, lithium sulfide. These are going to break down into ions. So I have 3 lithiums with a -2 charge, and yes, you must show the charges. And when these combine, it forms aluminum sulfide. That makes a solid. Okay? So this is my net ionic equation. Now, the reason why I don't include lithium and bromine, because lithium has a +1 charge, bromine has a -1 charge, and this is soluble. Also on this side, these things are soluble based on solubility rules. If you need to look up the rules here, again, they're there. Okay, these are solubles. Everything on the left side of the equation is ions. They're in solution, but they're in solution as ions. They're not solids anytime they have a charge. So I'm putting my aluminum and my sulfur ions in my net ionic equation. Now, what would you call lithium ions and bromine ions? They do have a special name because they remain as ions over here, and bromine ions over here and here. So there's 6 lithium ions, there's 6 bromine ions, and 6 lithium ions, and 6 bromine ions on both sides. They're both ions. These are called, if you go to a sporting event, you'll see a lot of these. And they're watching the action, but they're not involved in the activity. That's right, they're called spectator ions. Spectator ions are never included in a net ionic equation. Alright, never include the spectators. Alright, let's try another one. Net ionic equation. So we got to write out the whole thing first. So the bismuth 3 chlorate, so bismuth, Bi, and it has a +3 charge. How do I know that? Well, Roman numeral 3 there. Chlorate, ClO3, and it has a -1 charge. And we're going to react that with sodium with a +1 and hydroxide with a -1. Okay, let's flip these guys. Bismuth is now going to go with the hydroxide. And hydroxide is still -1. Bismuth is +3. And sodium with the chlorate. +1, -1. Okay. Looks like we need to put a parentheses here for the 3. Looks like we need a parentheses here for the 3. And everybody else looks balanced. Alright, so we have our no, we don't have our atoms. We have our charges equal on both sides. Now we have to have the same number of atoms. Alright, let's find one. Here we'll start here. We have 3 chlorates, so I need 3, so I'll put a 3 there. I have 3 sodiums, so I need to put a 3 there, and I'm balanced. 3 sodium, 3 sodium, 3 hydroxide, 3 hydroxide, 1 bismuth, 1 bismuth. Okay. Solubility rules. Bismuth hydroxide. As we stated earlier, all hydroxides are not soluble except for group 1A and calcium on down. Group 1A and calcium on down. Okay, so again, not soluble except for group 1A, calcium, strontium, and barium. So this forms a precipitate. Sodium chlorate, is that soluble or not soluble? Very good. All chlorates are soluble. Sodium is a group 1A metal. Both of those are reasons for a soluble compound. Alright, so writing the net ionic equation, we have 1 bismuth with a +3 charge, and we have 3 hydroxides, that's why we always want to balance, with a -1 charge, and it forms bismuth hydroxide. And you'll notice I'm putting an S here. The only time that we circle and write PPT is when we are doing our initial state, or stage here. Alright, the very last example here. Try this one on your own. Pause the video. Try to do the whole thing. I want you to be able to do this because You're going to see this on the AP exam. I promise you'll see something just like this on the AP exam. Alright, so calcium chloride, plus 2, minus 1, and lithium phosphate, plus 1. Phosphate is negative 3. So we'll have calcium with the phosphate, and negative 3 plus 2, and that's going to be with lithium chloride. Plus 1, minus 1. Okay, so lithium chloride looks good. Let's balance these guys out over here. So plus 2, we need 2 chlorines. Lithium has a plus, whoa! Lithium does not have a plus 3, it has a plus 1. Sorry about that. So a 1 there. So that means I need 3 lithiums. I think subconsciously I was thinking lithium is going to have a total charge of 3. We have a negative 3 charge here, so that means we need 3 calciums. We have a plus 2 charge here, that means we need 2 phosphates. Alright, so we have the charges balanced. Now let's make sure we get the same number of atoms on both sides. So let's go ugly early. We have 2 phosphates. We have 1. Put a 2 there. We now have 6 lithium. We now have 6 lithium. 6 chlorine. Put a 3 there. 3 calcium. 3 calcium. We're balanced. Okay? Solubility rules. Let's start with the lithium chloride just for kicks and giggles here. Lithium, group 1A, soluble. Alright, calcium phosphate. We haven't really talked about the phosphates here, but the phosphate goes hand in hand with the sulfide, carbonate, and chromate. Okay, so all phosphates are not soluble except with group 1A and ammonium. And we have calcium, which is in group 2A, forms a precipitate. Okay, and then the last step here, write the net ionic equation. How many calciums do we have? We have 3. Trying to write a plus 2 here, and it doesn't want to do that. Okay. Plus we have 2 phosphates. And again, do not write parentheses for your polys. Don't do it. And then we have calcium. Rewrite the whole formula. And then put a little solid on there. Okay. Alright guys, again, I cannot overemphasize how you need to make flashcards. You need to memorize the solubility rules. You also need to know your 10 polyatomics, names, charges, and formula. Okay? This is the part of chemistry that a lot of people don't enjoy because it's not math. There's no math on this other than balancing charges. I'm sorry, but this is part of the chemistry that we have to master for the AP exam. And if you don't master solubility rules and you don't remember what your polyatomics are, you're not going to make it to the second semester. Okay? So do this. Trust me. It takes a little bit of time, but this is summer and you have the time. Do it now. Hope this video has helped. If you have any questions, please do not hesitate and ask.